Hi, in this video, we're going to talk about what to do with the exponents when you're multiplying two different quantities or more quantities. We're going to go through several properties, and then we'll do several examples for each. Before we begin, if you have not subscribed so already, go ahead and click the subscribe button so you have more access to math videos like this one. Let's begin. Before we begin talking about rules of exponents, let's talk about what it is, right? Here we have an example of 5 to the third power. This means that we're really multiplying 5 times itself 3 times. We have 5 times 5 times 5. Now we can simplify 5 times 5 times 5, or write it as 5 to the third power. All in all, it's going to be the same thing as saying 125. 5 times 5 is 25, and 25 times 5 is 125. Here on the right, we have 4 to the third times 4 squared, which is the equivalent of saying 4 times 4 times 4 times, in this other scenario, 4 squared, which means 4 times itself twice. In the end, we're multiplying 4 times itself 5 times. Okay? So we can group all of these together and say we have 4 to the 5th power, which is going to be equivalent to 1024. So expanding it is really just writing another form of seeing this exponent. 5 to the third means we're multiplying the number times itself 3 times. Here, because we have a group of 3 and a group of 2, we're multiplying 4 times itself a total of 5 times, or 4 to the 5th. And that actually brings us to our first rule. Notice how in the previous example, we did 4 squared, which is 4 times 4, and 4 to the 5th meant we're multiplying 4 times itself 5 times. So 1, 2, 3, 4, 5. Because all of these numbers are 4s, we can group all of them together and say we're multiplying 4 times itself a total of 7 times. 4 to the 7th power. Now over here on the right, we have just a general scenario. What happens if you just have a variable? Okay, what happens if instead of numbers, we're dealing with a variable raised to another exponent? Well, similar property, right? Same thing comes up. In the first scenario here, we're dealing in n times 3, or n to the third power, meaning n times itself 3 times. And over here, we're doing the exact same thing. N times n times n. Since all of these are the same variable, we can combine them by saying we're multiplying n times itself a total of 6 times. If you notice the property here, what are we doing with all of these numbers? However many we have, notice how we have 2 here and then 5 here. When you combine them, you have 7 total. Here we have 3 and 3. When you combine them, you have 6 total. So we call this part of the exponent the base and this part the exponent. Whenever you're multiplying two things that have the same base, like 4 times 4, or n times n, or 5 times 5, anything, what you're going to do with the exponents, to combine them, the total is going to be x plus y. So you can say, this is the same thing as saying a to the x plus y. And that's actually what's going to be our property. A and a are the same base, so we can just add the exponents to combine the numbers a lot faster. Instead of expanding them, we can just group these two together, knowing that we're going to have a total of 7 4s, or a total of 6 n's. So let's apply this property into practice. Here we have 3x to the 4th and 5x to the 5th. Now, I want to first talk about combining like terms. Since you're multiplying, I'm going to be able to combine the 3 and the 5. So I'm going to separate this over here. I can say I have 3 times 5. Those are like terms. Those are going to be grouped together. At the same time, I can group the variables together, the x to the 4th and x to the 5th. Since we're going to have right? The question you want to ask yourself is, well, let's first combine them. We have x to the fourth times x to the fifth. Now that they're sort of grouped together where they belong, let's multiply things. Here I have 3 times 5. Now that is just the number I know. 3 times 5 is 15. Over here, I ask myself, how many x's will I have in total? Right? X to the fourth, x to the fifth. Notice how the x's are now the base. We add the exponents. So 4 plus 5, we get 9. And I'll put this in red. X to the 9th power. In the end, this is going to be the equivalent expression of 3x to the fourth times 5x to the fifth. You combine the like terms, the numbers go together, and then the variables to go together. And if they're the same like terms, meaning they have the same base, you can add the exponents to get 9. Let's give this one a try. Which ones will be grouped together? Well, the 4 and the 6 will be grouped together, the x's will be grouped together, and the y's will be grouped together. And I'll do those in different colors. I'll combine first the numbers. 4 and the 6 are like terms. So I really have 4 times 6. Then I can combine the x's. I'll make that in red. I have x to the third times x squared. And then lastly, I have the y's. I have y times y to the third. Now, once they are sort of combined in like terms, I can actually multiply things that I can multiply. So I start with 4 times 6. 4 times 6 is just 24. And then I move over to the x's. Combining x to the third times x squared, how many x's do I have in total? I have x to the fifth. And then at the end, here I have the y values. Y, technically this y value has an imaginary 1 as an exponent because there's only one y there. So if we add the exponents, I have y to the fourth power. Sorry. Now, in the end, all of these terms are being multiplied. So technically it's 15x to the 9, 24x to the fifth times y to the fourth. Everything's being multiplied. But that's how you combine them. You combine the like terms, so the numbers go with each other, the x's go together, and the y's go together. And in the end, we can add the exponents with the variables. So this is called product of powers. If you're multiplying two things, you can add the exponents. Let's talk about this next property, the power of a power. What happens when you have something that has an exponent and you raise it to another exponent? Well, let's break it down. 2 squared to the third power really means I have this term in the parentheses multiplied by itself 3 times. So what I can say is really that I have 2 squared times itself a total of 3 times. 2 squared times 2 squared times 2 squared. I did it 3 times. Now, since they all have the same base, how do I combine the numbers? If they have the same base, I can just add the exponents, right? That was the rule in the previous example. You can add the exponents. So, how many 2's do I have in total? Well, I have 2 plus 2 plus 2. And I have a total of 6. 2 to the 6th power. Now, the rule here, if you can tell, is that I'm going to end up having these exponents adding to each other. Another thing that I could do is I can just multiply these two exponents. So when you have an exponent raised to another exponent or a power raised to another power, right? Sorry, let me back up really quick. I made a mistake. Let's trace back a little bit because let's scratch what I just said. Okay. So what is happening here, I'm going to switch into 2 different colors. Let's back up. We're correct with the idea that 2 squared to the third power means 2 squared times itself 3 times. What's happening here, right, is I'm raising this to an exponent. So I'm going to add up the terms. 2 plus 2 plus 2, which gives me 2 to the 6th power. Now, 2 to the 6th power actually equals a number, right? So I can simplify further. 2 times 2 times 2 times 2 times 2 times 2, which gives me a total of 64. Right? So if you're just dealing with numbers and no variables, it's just going to equal another number. But like I said earlier, let's break down what actually happened. An exponent raised to another exponent, instead of just adding the exponent, expanding the form, and then adding the exponents, you can skip that step by figuring out how many of these am I going to have. I'm going to have 2 3 times. So in the end, I have 6 of those. I can multiply the exponents to each other. Okay? I have 2 as the base, and then to the 3rd power is to the 6th. So 2 times 3 is 6. So my rule here is I raise my exponent and I multiply it times the other. And that's the property here that I'm dealing with. You raise the exponent to another exponent, you multiply those exponents together. If it's a number, you simplify it to an actual number. But if it's a variable, you leave it as a variable. And I'll do an example here so you can better see what I'm talking about. So the rule here, right? Notice how here, before we do some examples, now I actually have another term. I have 2 terms. I have a 3 and I have a 4. Sorry, a 3 and an x. So I have 2 different terms being raised to an exponent. So what's actually happening here is I'll do the expanded version first so you can see it, and then I'll shrink it a little bit. I'm really doing 3x squared times itself 4 times. This term is raised to the 4th power. So I'm multiplying it by itself a total of 4 times. Sorry, let's make that a 2 at the end. So I can group the numbers with the numbers, right, which is all the 3's. So what I really have is 3 times 3 times 3 times 3. And then the x's, I'll combine those together because those are like terms. X times x squared times x squared times x squared. So I have that 4 times. Notice how both terms inside the parentheses, the 3 and the x squared, both of them were written 4 times. The 3's were written 4 times and the x squares were written 4 times. When I try to combine them, here I really have is 3 to the 4th power, which equals a number. That should equal to 3 times 3 times 3 times 3. That's equal to 81. And then over here, how many x squares do I have? Well, I have 2 plus 2 plus 2 plus 2. That's equal to 8. 8 x's. Okay? When I combine these two, I have 81. Let's group it together. My answer combined will come down to 81x squared. Sorry, x to the 8th, as I combine these things. Now, what actually happened here? Okay, let's break this down. I have this number to the 4th power and this term to the 4th power as well. So what's really happening here is more like a distributive property. I have the 4 is going to go in here as an exponent to 3 to the 4th and to the x squared. So technically I have x squared to the 4th as well. The 3 is raised to the power and the x squared is raised to a power. And since we said that a power raised to a power is really multiplication, we do 4 times 2, and that's how we got the 8. So we have 3 to the 4th and x to the 8th. Since 3 to the 4th is just a number, that's how we got 81, x to the 8th. Okay? So whenever you see multiple terms inside of a parentheses raised to a power, what you're going to want to do is you're going to want to multiply, give that exponent into every single one of them. We're going to distribute the x. This x is going to go into the a and into the b, and it's going to be the exponent of both terms inside. Or multiple if we have more. So we can say a to the x and b to the x. Notice how both terms inside the parentheses will now have that same exponent from the outside. Let's try some examples of all of these rules combined. So, let's recap a little bit. Here I have 3 terms. I'm going to raise each of these terms to the third power because I have multiple exponents. Right? So, 7, C, and D, all 3 terms will be raised to the third power. That's my distribution. I'm going to distribute the 3 into all these 3 terms. So I have 7 to the third times C to the third times D to the third. The only thing that I can actually simplify is 7 to the third power because it's just a number. And I have 7 times 7 times 7 is the same thing as saying 343. And then I just write the variables the way they are. On this other term, now I have more terms. I have 1, 2, 3, 4 total terms being raised to the second power. So I have negative 12 squared, a6 squared, b to the 5th squared, and c squared. And I'm going to write those sort of separately. Okay, I have negative 12 to the second power. I have this a to the 6th to the second power. I have b to the 5th power, also to the second power, and lastly, the last term, c, to the second power. Every term inside the parentheses will be raised to the second exponent. Negative 12 squared is really just negative 12 times negative 12, which is 144. A to the 6th power to the second power, right? An exponent raised to another exponent means you multiply. 6 times 2 is 12. So this is a to the 12th power. B to the 5th to the second means we multiply 5 times 2. So we get times b to the 10th power. And then lastly, c to the 1 power. Technically there's a 1 here that I can add. Raised to the second power, 1 times 2 is 2. So we have c squared. So the more terms you have, all this really means every term separately will be raised to that same exponent. You just have to distribute the 2 into every single one of those terms. And if there's already an exponent there, you raise that exponent to another exponent, which means we multiply the exponents. Okay, so let's put this all to use. Let's put it all together, combine all of these rules so we can see if we can put them all to practice. Here we have this long term. This is the most complex that this property of multiplication is going to come to. Right? So far, all we've been doing has been multiplying all of these terms together. So let's break things down a little bit. I have everything in the parentheses will be raised to the second power. And everything over here, except for the 2, right? The y to the third, that will be raised to the 4th power. So let's break things up a little bit. On the left, I have the parentheses, I have 4 to the second, x squared to the second, and y to the second. Technically, I guess I can put the 4 in parentheses as well. Every term here was raised to the second power. Now, the 2 is not inside the parentheses, so I'm just going to write the 2 the way that it is, times 2. But now, the y to the third, that is going to be raised to the 4th power. So I copy that over here. Y cubed to the 4th. Now we come into the property of the power to a power exponent. An exponent to raise to another exponent means we multiply the exponents. So here we just have 4 squared, which gives us 16. Here we have x squared squared, so 2 times 2 is 4. So times x to the 4th power. Y squared is just y squared, right? Because technically we have y to the 1 power here. 1 times 2 is still 2. On the right, we have 2 times y cubed to the 4th power. 3 times 4 is 12. Notice how all of the parentheses have disappeared. And now I can start coming back together and group things that are like terms. And I'm going to do that with colors. So to combine everything together, once the exponents have disappeared, the exponents to the other exponents, the 16 and the 2 are like terms because they're numbers. So 16 times 2 is 32. Then I look at the x's. There's only one x. There's no x on this side. So I bring the x next. X to the 4th. Times x to the 4th. And then lastly I have, let's do this one in blue. Or I guess black. The y's. Those are going to be grouped together. What happens when we're multiplying, right? How many y's do we have total? Well, I have 2 here and I have 12 over here. Combined, I'll have 14 total y's. We always want to write things in alphabetical order. So if we have multiple variables like z, right, w, x, y, z, all of these, you want to put things in alphabetical order in the bottom. And this is it. We combine the x's with the x's, the y's with the y's, and the numbers with the numbers. Okay? So here we combine all the rules possible. Exponents raised to exponents, and then at the end, the product property when you're multiplying, right, like y squared times y to the 4th, you add the exponents because you have a total of 14 y's. All right, guys, I hope this has helped. If you have learned something from this video, click the like button. And if you haven't done so already, go ahead and subscribe. All right, everyone. As always, we'll calculate later.